Hi, everyone. My name is Lou Montano. To begin, I would like to take a moment to thank everyone that's joining us today to go through one of 5 live demos on various topics that we have scheduled for you this week. If you'd like to learn more about our other highlighted products and services, please check out the presentations that we have listed on our website. Okay, we're about to go into presentation mode now. I'll be speaking over slides that will be showing you. So just hang tight. We're going to go to slide 1 here in a second. Okay, today's presentation is our most recent design, the standalone ultrasonic sealing module for reciprocating vertical form fill and seal machines. If anyone has any questions throughout the presentation, please feel free to start a chat. We have engineers online to answer any questions, or feel free to contact us after the show. More than 1976. And over the years, we have excelled as a leader in the industry, providing quality aftermarket tooling, engineering services, and complete packaging solutions related to sealing, cutting, and punching. In addition to these products and services, over the last few years, we've broadened our knowledge of ultrasonic sealing and expanded our expertise in designing, manufacturing, and integrating ultrasonic retrofit packages onto existing vertical baggers and horizontal pouch machines. Today, I'm going to discuss the most widely used conventional method for integrating ultrasonics onto existing baggers, and then I'm going to review the challenges associated with that method. Then I'm going to transition into discussing our topic for today, the standalone ultrasonic sealing module. This is our latest design and ideal solution on how to economically retrofit existing baggers with ultrasonic sealing technology. I will also highlight the benefits in using the standalone retrofit method over the traditional method. Okay, shown here is an older Woodman Polaris bagger that we converted using the conventional method. When we use this method, standard protocol is to design and manufacture components that will fit onto the existing bagger to support and hold the ultrasonic tooling. This usually consists of larger carriages, that you can see here, larger diameter guide rods if they're used. In this instance, it was linkage arms and other components. And in some instances, a counterbalance system is required to overcome the shaking and vibration when operating at higher speeds due to the additional weight of the ultrasonic tooling. In this picture, you're going to see the difference in the size of the tooling. The heat seal system on the left uses much smaller carriages and heated jaws, while the machine converted to ultrasonic shown on the right side has larger redesigned components that were manufactured to support the ultrasonic tooling. Now, in addition to dealing with the problematic additional weight and larger components, another limiting factor of the conventional method is having to utilize the existing motion of the bagger, which also means using whatever the maximum seal force that particular machine can output. Here's a show showing the sealing process and provided by a traditional bagger. Now, whether that sealing motion is pneumatically or mechanically actuated, each bagger has a maximum seal force that it can output. This makes this type of conversion complicated in providing accurate, precise, and certified seals. Another challenge of the conventional method is working on older equipment. For instance, here's that same image you saw earlier of the older Woodman Polaris. When working with older machines like this, there can be existing wear parts or drive components that may be worn and need to be replaced prior to even starting the conversion, such as belts, motors, electrical components, bearings, or even bushings. Also, as I mentioned earlier, the sealing motion of these older baggers may not have sufficient seal force required to support the ultrasonic process. Another very costly challenge is a project that requires converting multiple machines from various manufacturers. This automatically multiplies the number of designs to complete the conversions, which adds a lot of engineering and manufacturing costs. Okay, everything that I've discussed up to this point describes the variables associated with the conventional method of converting a bagger. All of these variables add complexity and cost to a project. So, to simplify the process, we developed a cost-effective solution to overcome these obstacles, which brings us to our topic for today, standalone ultrasonic sealing module for vertical machines. Okay, I'm going to be loading several slides here, showing you different images of the standalone unit. This first slide is a front view of the unit. Here's an elevated view, and to give you a perspective of which way the unit is facing, the control, the HMI that you see here is toward the front. I do need to say that this particular unit was designed and built specifically for show purposes. And what I mean is the difference from the unit shown here and a production unit will be the mounting location of the HMI controller. The show unit has the control mounted for show display purposes only, while a production unit will have the control mounted close to the bagger HMI or possibly even inside the electrical enclosure of the bagger. As you can see, this unit is ready to be integrated into any vertical bagger with reciprocating motion. So now let me take you through some of the advantages when choosing this system over the conventional conversion process. Okay, for starters, we have an evaluation process that the existing machine or machines to be converted need to go through. Well, this evaluation process now becomes much simpler. And what does this mean? This means that the initial visit to a customer's facility to inspect the bagger or baggers to be converted consists basically of measuring the space where the existing heat seal jaws and carriages reside to ensure that once those items are removed, there is sufficient real estate within the safety door compartment to fit the standalone unit. The slide that you've been seeing is a solid model illustrating the compartment measurement that will help us determine the size of the standalone unit to be implemented. Okay, here's another solid model illustrating the standalone unit once it is mounted in place. Now, in addition to calculating space requirements to fit the standalone, the engineer is also going to review current signals coming from the existing bagger during its production cycle to determine which of those signals can be used as a go signal when integrating and firing the ultrasonic unit. Another big advantage of using a modular design is the ability to use the same unit when converting multiple baggers from different manufacturers. As I mentioned earlier, when working with various bagger types, we simply need to ensure that the space inside the safety door compartments will fit a common design standalone unit. This means we can use the same standalone design for various bagger types, which will reduce the number of spare mechanical or ultrasonic components that a customer is going to need to have on the shelf. This next benefit, which is the sealing force, is especially important because it was designed to support the requirements of ultrasonic sealing. The video that you're watching here is a sealing motion of the standalone. With this standalone, we're not limited to whatever seal force is provided by the bagger. If you recall, I mentioned earlier that when converting a bagger using the conventional method, you're locked into whatever seal force that particular bagger can output. The standalone unit was designed with load cell feedback and is driven by a stepper motor. Therefore, the precise ramp up speed, closure location, initial closure sealing force, and the final sealing force can all be controlled based on the required production output or packages per minute. Okay, this brings us to the features of the color touchscreen HMI interface, which comes standard with each standalone unit. The HMI provides flexibility to control the ultrasonic system and changes the parameters that control the sealing process. I'm going to be showing images of the different pages available on the standalone HMI. As we go through these, I'll explain the various settings and control features. This particular screen is the welcome or home page. This page allows you to access various pages that are going to be used to either set up or control the standalone unit. This is the seal force page. From here, you can input an accurate final seal force to be applied on the pouch at the time the ultrasonics is fired. This setting can be accurately adjusted up or down because we use a load cell system to provide force feedback. Once the sonotrode and anvil close on the pouch, and the controller records an initial force measurement, the HMI will automatically do the calculation for the drive motor to apply the desired force that was input on this page. This is the alarm setup page. Anytime an alarm prompt is flashing, doesn't matter what page you're in, you can access the alarm setup page by simply touching the flashing alarm prompt. Once this page opens, you click on the alarm to find out what the cause was and what action is required. These alarms can also be set up to be sent to a remote location, such as a control server or possibly a cloud. Examples of alarms can be if a device has failed, if there was an ultrasonic problem, or possibly even a package quality issue. The recipe page is useful for companies that run different pouch sizes and/or various films. Once you have adjusted the various setup parameters, such as the seal force, the wattage, weld time, amplitude, and frequency, and you have that certain pouch size and film running well, you simply establish a name for that recipe and save it to be loaded anytime for future runs. The heater temperature control page, well, this is an optional feature that we added since this unit can also be equipped and used for heat sealing. For instance, if someone wanted to run heat seal, we would manufacture and mount standard heated jaws, and this page would be used to set up and adjust the temperature of the jaws. The ultrasonic setup page is used to input and or change the wattage, the weld time, amplitude, frequency, and start signal. Normally, these settings would be set and adjusted on the ultrasonic generator, but with the standalone unit, the generator is going to be integrated so that these settings can be manipulated from the controller on the standalone. The motion setup page is used for the initial production setup. For instance, setting up the seal timing with the film registration mark and product fill, or setting the jaw opening and closing positions based on the pouch thickness, or setting the knife firing delay time. Basically, this page, what you do here is synchronize the standalone with the bagger during production. All these settings will also be linked to a recipe and can be loaded once that recipe is loaded. And finally, we have the operation page. This page allows you to monitor the settings during production that were input on the motion setup page. Settings here cannot be changed, that can only be monitored on this page. This concludes my demonstration for today. I hope this information was valuable. Okay, if you'd like to know more information, we still have a few minutes left here. Please send your questions via chat. We have engineers on staff ready to answer any of your questions. Or feel free to visit our website, contact your regional sales engineer, or call the office here direct. Also, please don't forget to visit our virtual booth. Thank you again for attending the show. Appreciate it.